Now that we know about complex numbers, we can add, subtract, and multiply them. Let's look at example A. I simply add the real number components and then add the imaginary components. Be careful, I is really 1i, so 6i plus I is 7i. Be sure to maintain the proper formatting, a plus bi. Example B, subtracting, no problem, right? Wait, we're not going to leave it in this form. I want you to rewrite this to eliminate the possibility of making any minor error. We don't want to lose points. When we get to the minus sign, remember, it's like distributing a -1 into the binomial. We have to account for the fact that we are subtracting both terms in the binomial. Now it's just like addition. Let's do it. Example C, all we're doing is multiplying by a monomial. No worries. Let's distribute 3i. Whoa, this looks a little, not sure. Wait a second. Remember back when things got real? Yes, I squared is -1. So 6i squared is not 6i squared. It's 6 times -1. That's -6. Never okay to leave something as I squared. That's like not simplifying it. So once I have 6i squared is a -6, I have -15i minus 6. Whoa, that's not correct format. A plus bi, real number plus or minus the imaginary number. So final proper answer is -6 minus 15i. Now we're just multiplying complex numbers again, but this time they're both binomials. Let's go ahead and expand. Be careful. This is a good time to make sure you distributed correctly. So distributing the 4 into the second binomial, -4 minus 8i, and then distributing the 3i into the second binomial, -3i minus 6i squared. We already talked about the fact that we do not leave I squareds as one of our terms, so we need to simplify that. -6 times -1. This now becomes plus 6. Then we have to combine like terms. Combine your real numbers, combine your imaginary. Final answer, 2 minus 11i. Remember the form is very important. Now you get to try. Add, subtract, and multiply complex numbers. Pay careful attention to whether or not there is an operation between the sets of parentheses. If there is, then we're not multiplying. Check your work. Make sure on F that you distributed that minus sign and have the correct final answer, and check your final form on each of them. But hey, take a look at H. Isn't that so cool? We multiplied 2 complex number binomials and got a real number. I wonder how this could be useful. Miss Ryan?
Well, H, those 2 binomials were conjugates of each other, complex conjugates, so we ended up with a real number. So if we have a plus bi as our complex number, then its conjugate is a minus bi. We just changed the middle sign. If we have a minus bi, then its conjugate is a plus bi. We just changed the middle sign. So let's practice this. I'll do the first one. -3 plus I. Its conjugate would be -3 minus I. All I changed was the middle sign.
Does -3 become 3?
No, a conjugate is only that middle sign changing. So -3 stays -3. The plus in the middle changes to minus. You do the next 3. Check those conjugates. Now, why would we need this? Why would I care that a complex multiplied by its complex conjugate is a real number? Well, check this next example. If I have a quotient, -1 plus 5i divided by 3 minus 2i, I want to write that as a complex number in proper form. So that means I need a real part plus its imaginary part. In order to separate this into a plus bi, a complex number's proper form, I need a real number in the denominator. So I could kind of force that using a conjugate. My denominator is 3 minus 2i. Well, what's the conjugate of 3 minus 2i? 3 plus 2i. If I multiply the denominator by 3 plus 2i, I know it'll become a real number. Now, this is algebra, right? I can't just multiply by whatever I want. I have to make it a creative form of 1. So whatever I do to the denominator, I'm also going to multiply to the numerator. That way I'm just multiplying by a creative form of 1. Now this is our first time trying this, so I'm going to be really careful. I'm going to multiply out that numerator, multiply out that denominator, and then combine like terms. All right, really check that your numerator and denominator are the same as mine. If I made a mistake in this first step, it's gonna mess up all the rest of my steps. Looking at just the numerator, I've got some i's that I can combine, and then I have this plus 10i squared. Well, remember, I squared is just -1, so that's really gonna be 10 times -1, so it's gonna be a minus 10. So what can I simplify now in the numerator? I've got my real numbers, my -3 minus 10 is -13, and then my imaginary is -2i plus 15i is positive 13i. And look at that, I already wrote real part first, imaginary part second. Okay, same deal with the denominator. Let's look to see what we have. We have some i's that we can combine, and we have that minus 4i squared. Well, I squared is really -1. -4 times -1 is positive 4. Real parts, 9 plus 4 is 13. Imaginary parts, 6i minus 6i. Oh, those add out. So I'm left with -13 plus 13i, all divided by 13. So I got -13 divided by 13 plus 13i divided by 13. Well, those 13s divide out, so I'm left with -1 plus I. Looking at this next example, what's the conjugate? How are you going to write it as a creative form of 1? Go. Did you write 2 minus 3i divided by 2 minus 3i? Woo! Now it's time to multiply that numerator, multiply the denominator. Be careful. Let's see how you're doing on I. Did you get -14 divided by 13 minus 18i divided by 13? All right, looking at J, what complex conjugate do I need to multiply by? Always look at the denominator, right? Because it's the denominator we're trying to make real. If you've got a conjugate of 4 plus 3i, you're spot on. Now write it as a creative form of 1 and get going. My final answer simplified down to 1/5 plus 2i divided by 5.
As I look at the next example, I see a monomial in the denominator. Do I need a complex conjugate? No, I just need to make it so that it says 7i squared, because I squared is -1 and it's back to real. So if I multiply by I in the denominator, I multiply by I in the numerator. Be sure you multiply I into the 5 plus 4i. So 5i minus 4, all divided by -7. I need to get it into a plus bi form, so I'll split that into 2 fractions. Also put the real number in front. Then let's clean up. -4 divided by -7 is positive 4 sevenths minus 5i divided by 7. Let's have you do the last one and check with me for the final answer. Two minus 7i. And look how much we've learned.